And so here we are. We get to share an amazing story today of a school building. And we've got three great presenters today. So sorry, I didn't quite get ready with my intro because I had such a great session with the breakout team there. So we have David, Dan, and Brendan. David Mead is with PAE. He leads the regenerative design group at PAE, bringing experience as a high performance building specialist and architect. We have Dan Swaab, who's involved in planning and design a variety of commercial, retail, residential, institutional, and hospitality projects. We also have Brendan Connolly, who also partner with Dan at Mithun, and he works nationally on education projects, student housing, and cooperative workplaces, all with the same attention to design and high-performing sustainable buildings and landscapes. I'm really looking forward to this presentation. I think schools are a great candidate for developing passive house across our planet, because not only do the students and children benefit from an amazing building, but they become showcases and pillars in our communities, and hopefully then people want to adopt them and want to live in them. So I will turn it over to our presenters today. I look forward to this, and you guys have the floor. Right, let's get the slideshow up and let's dive into learning about an amazing school in the Pacific Northwest. Over to you guys.
All right. Thank you, Sean. And I just want to say thank you to everyone for making time today and having us a part of this conversation. We've been really excited to be part of some past conversations with Passive House Accelerator and Zach and team. And it's really, this is a kind of ripple in the pond for our team that is continuing to grow, and it's influencing other projects. So we're going to be talking about the Bush School. This is a great project, but I just want to maybe start off saying that there are a number of other projects on the boards and nearing the end of construction that this project has helped to catalyze with Passive House. And so we're really excited about this growing as a part of our practice. I'm Brendan Connolly. I'm an architect and managing partner with Mithun. I focus much of my time on education projects, which I love, including a lot of K-12 environments like this one, because the clients are often deeply committed to affecting change through sustainable strategies like this. And Bush School being one of the top of the pile in terms of their willingness to commit to something that actually is meaningful and visible to the external community. Quick notes, working with Dan for the last 20 years. He's amazing. Also David for over a decade on sustainable projects with PAE, and these have been great partners on the work that we do. I'm going to give you a quick overview, and then Dan and David are going to dive into a little bit more detail on the project. But what you're looking at is the new addition to the Bush School for the upper school. It's an academic facility as well as a multi-purpose and gathering addition to this fairly extensive urban campus in Seattle. It's adjacent to the original building on the left-hand side of this image, which is the 1924 historic Gracemont project. And one of the interesting things about the new building is that it has mechanical systems that are symbiotically connected to the existing historic building, and it's about 10 feet away. So it's kind of a nested relationship between two cousins who are wood frame. One is mass timber. They're both brick buildings, but one is sort of leading to the future and the next generation of the students, and one is sort of the past. So quickly to kind of move us through, a quick thing about Mithun, I think many of our projects we're always looking for something that actually affects positive change beyond the property boundary, and this project has definitely been a big part of that. We've had the good fortune of working with a lot of different innovative school clients across the board, and many of these have chosen their own path. And I would say that the Passive House is a strategy that has been both tangible and meaningful in terms of energy performance and visibility to students. And so we're really excited for that to actually be a lesson that continues to learn or continues to be visible. Our work also ties to research and development. We have an internally funded grant program for R&D work that Passive House is one of a number of layers that we are exploring in more detail in terms of assemblies and strategies at a more nuanced level, but that's really exciting piece of it. So maybe to ground you all, I just wanted to talk a little bit about the context of this project. And it sounds like a few of you know Seattle, but the sort of core of downtown is off to the left. The Bush School is in the Madison Valley. It's actually facing Lake Washington, which is a body of water off to the right. It is a linear urban campus in a single family precinct of the city. So a lot of really tight zoning constraints and adjacent neighbors. It was founded about a century ago next year as kind of an independent school program with Helen Bush as sort of the originator of the school. Currently about 700 students, full K through 12, one of the few schools in the area or in the country really that has a sort of full K through 12 curriculum in this kind of urban place. High percentage of diversity and a really sort of innovative curriculum with a lot of indoor and outdoor experiential programs. But they're really committed to being a part of the city. And I would say that schools are important to Sean's comments. Schools and cities to us are even more important because they kind of convey a dedication to creating vitality and that kind of relationship between living, learning, and being in urban places, which are so important. One really important thing about this project, there's a 60-foot grade change on campus, and we were really struck at the beginning of our work with the accessibility requirements and the fact that previously there was no accessible way to get up to this project. So in addition to all the energy things, one of the things we dedicated ourselves to is to thinking about how we actually use the building as a bridge for access and universal design. And so urban campus, it's split by an historic Olmsted Boulevard that is sort of separating the upper campus from the lower campus. And our building is sort of on the right-hand side here, perched up at the highest point of the campus. We sort of took this idea of the intergenerational experience pretty heartfelt early on, and the idea of safe crossing and how we create accessible linkages to connect these two halves of the project. So the project really has two front doors, one that's a part of the upper school courtyard space, if you will, and the other one that actually fronts on the Lake Washington Boulevard to allow access and kind of a sort of front door at two different stratification points. The project itself was a really meant to be a visible front door and a kind of symbol of a lantern of learning to the school. And so we had to couple those strategies with how we thought about Passive House and balancing that. So right now, this photograph is inside the student living center, which is a sort of very visible front porch to the school. But we used a kind of tempering strategy with other parts of the program to really kind of get the envelope and all the spaces in balance. And so this is that lower entry off of Lake Washington Boulevard. It's set down about 18 feet, and there's a series of bioinfiltration and rain garden strategies that contribute to salmon safe. And then the project has a number of architectural ideas here, but one of the key ones was sort of breaking down the scale to this urban neighborhood and thinking about how we also create sort of parts of it that were more innovative and parts of it that maybe were a nod to the more traditional fabric of the campus. But we wanted the Passive House strategies to be very visible, as well as the mass timber that was integrated in the project. And so this is a look at kind of that relationship and the idea that we're expressing some of the mass plywood and mass timber elements sort of more front and center, and then the idea that there's a lot of visibility and transparency. Getting daylight into classrooms, avoiding those 2 o'clock doldrums that Sean mentioned, really vital. And so all the classroom spaces, to the extent possible, had balanced daylight on multiple sides, as well as kind of ventilation opportunities. The project actually is an interesting sort of mix of academic and gathering spaces up top with shared breakout learning, and then down below, there's actually this sort of, we avoided the idea of a parking garage early on in the planning and actually converted that to the idea of a larger classroom and multi-purpose gathering space that actually is the only place in the school that all 400 students for the upper division can gather in one place. So it was kind of a vital part of the campus in a way. And then finding spaces in this pretty tight urban space for breakout, for learning, for connecting kids with nature, creating those biophilic connections, both to the structure of the building, but also to the surrounding canopy, a really vital part of that. And also expressing the strategies where we could. So what you're seeing here is sort of found spaces for gathering and learning, but also using mass plywood in kind of ways to create furnishings and corner guards and signage that make the kind of building systems more legible. And that's kind of a key part of letting this be a learning tool. And so quickly, this project actually has helped the school achieve Salmon Safe accreditation. It was one of the first projects in the country to do that, which was a really sort of big accomplishment, which helps to improve the quality for salmon habitat in our greater region. There's a lot of stories in Seattle about combined storm and sewer overflow that really need attention for the habitat and health of ecology. A lot of great integration with landscape design and stormwater management and making those visible as well. We'll get into that in detail here. And then the idea of really connecting indoor and outdoor spaces through every way possible and really kind of allowing students to feel like they are both inside and outside at the same time. The other major accomplishments, though, in terms of metrics, Passive House is, of course, was front and center. The school expressed an interest in energy and water early on as kind of key priorities. And we really latched on and presented, what if Passive House and how could we get there, and really kind of working with them to achieve this within a very, I would say, a very sort of important construct of preserving the strategy despite a lot of value engineering pressures during the pandemic. We were able to hold on to this and kind of protect it as kind of a core goal and really rally a lot of support around the school. And David, PAE, huge advocates on this as well, and they'll talk more about that. And the third leg of our kind of performance stool here is really net zero energy, and the idea that the school is actually balancing that with on-site renewable energy on the broader campus to achieve this. But really excited about the project. It's really, in addition to the Passive House team, we had about 20 or 30 tours, and this has led to projects that are actually kind of developing this at an even bigger scale. We have one finishing construction at Princeton University that's about 10 times the size, as well as a new project at Georgia Tech that's under design that they've come to tour this project and really have been excited about this as a case statement and proof in the pudding that you can actually kind of scale up with these strategies in a thoughtful way. So I'm going to pass the torch to Dan to talk a little bit about how we got here.
Okay, thanks, Brendan. So I'm Dan Swaab, principal at Mithun, mostly on the technical side, but I was the project manager and project architect on this project. So, as we know with every project, a lot of coordination, collaboration between team members, Passive House, even more so. So great relationship with our owner, all of our design team members, contractor, who we had a change of contractors sort of midway through the project. So we'll kind of talk a little bit about that later. But we also had the donor group and being sort of responsible and for their funds and keeping them apprised of developments of the project. So next. So with that in mind, with any project we do, we bring a level of sustainability mindfulness to the project. And so this was an early spreadsheet created to just identify all of the sustainability ideas that we could think of for this type of project, and as a vehicle for helping the owner make decisions. So, and throughout this whole process, we needed to keep in mind what was a baseline code compliant project versus what was a high performance upgrade to the project. And this relates to the donor funds specifically earmarked for sustainability measures for the project. So we looked at a bunch of maybe just go to the next slide. I know you really can't read too much of this spreadsheet. There's a blow up portion of that. So we looked at a lot of different categories for glazing and solar access, renewable energy, things like that. But in this particular case, we were looking at the roof, wall, floor glazing systems, really directly out of the Seattle Building Code, what was required as a baseline code building, and then what we would propose as a high performance approach, and then identified what sustainability system that would contribute to, whether it was Passive House or LEED. This was a sort of a decision-making matrix. As we started to settle on Passive House, we would then find those strategies that contributed to that particular rating system and focus on those. We had a very rudimentary cost analysis of $1 sign to $5 signs of how much we thought those strategies might cost, and this was before the contractor really dug into pricing on these. So maybe next. And carbon was also a big story that came up with the client, and so we did analyze two different structural systems of wood versus steel, and did some tally modeling in-house on a representative system where we basically came out with some outputs of quantity of energy to create the system. And so the client sort of grabbed onto that and was excited about a low carbon building. So we were able to get a wood timber post and beam structure. Next. So once we settled on sort of Passive House, net zero energy, and low carbon, we boiled down the strategies that we were going to focus on for the project. Again, keeping in mind baseline versus what our project was going to target. And gave that list to the contractor and said, okay, now we need to price these separately. So next slide. Contractor took our list and created their own matrix, again, with pricing on the left for the baseline building versus what we were proposing on the right. A lot of these were sort of add alternates in our documentation. And we had a pot of money from this donor group earmarked towards sustainability metrics. So we really needed to show the delta between what the baseline was and what we wanted to propose. So the major systems, structural systems, insulation, fenestration, HVAC systems, a lot of these had upgrade costs to achieve our sustainability goals. So next. So one item, for example, windows, we were looking at an aluminum frame storefront system, as good as we could get as our baseline. And that window package was about $200,000 for the building to achieve our passive house standards. And in the design that we wanted, we ended up proposing Cascadia fiberglass windows, triple pane with a U value of 0.15. There was a $185,000 delta to use those windows. So not insignificant, but a big part of the success of the envelope. Next. So like I said, we had a changeover of contractor kind of midway through the project or kind of late in the game. So this was kind of midway through CDs, where we had the new contractor on board, and we really focused on constructability. And so, these were detail sheets that we had in the set. The contractor went in and marked them up with suggestions, things that they didn't think were going to be constructible, or they wanted to propose a different way to do things. They hadn't been in a lot of the meetings of, the need for good thermal bridging, design. So, the detail on the left was what we were originally proposing with these stem walls that were elevated up off the main structure separated with insulation. They wanted us to connect down to the foundation with those. We worked with PAE to do therm modeling on a lot of our details, kind of the big typical details, as well as some of these specialty details, and kind of vetted some of these suggestions the contractor was bringing to us for constructability. Next. So these are just some construction photos. We have full insulation under the basement slab. We didn't do insulation under the footings of the columns and perimeter foundation walls. That was deemed a little bit too complex and some risk with that the folks didn't want to take on. But these details were, verified with the WUFI model and therm modeling. We used all EPS insulation. Next slide. As much as possible to avoid XPS insulation and the global warming potential of that. So exterior 2 inches of exterior EPS insulation around the perimeter. Next. So, the wood timber structure was great. We used mass plywood panels from Ferrer's out of Oregon. If you're not familiar with that, they're very large plywood panels, basically in 1 inch thick increments. You can get, 8 feet by 40 foot panels. So the structure was refined to minimize the fiber content. So we have beams about every 5 feet on center and 2 inch thick mass plywood panels. Next. The window insulation, to the contractor's credit, they sent their superintendent and some others to passive house training to learn how to create a really tight window opening, and we did mock-ups on site. This is a shot of our Intello Plus interior air barrier and the sealing of it. Next. And there's just some construction shots kind of showing early design sketches by Brendan, some 3D renderings we did on the lower left, and then sort of construction shot with it coming together. That's the wrap shield SA product on the weather barrier. And I think this is the last shot of my portion here. So this is just a construction shot of it all coming together in the context with the Gracemont Mansion to the right and the forest to the left. A lot of exceptional trees on the site that we were nestling this building in between as well, and it's steep slopes, so challenging site.
Yeah, I just wanted to mention that the footprint was really vital, and so we couldn't just sort of expand the assembly outward. There was a lot of sort of working from the outside in this project to kind of preserve both program, but also the tree roots that were all around us. David, I think you're up.
Yep. All right, so one of the key things for this project and any larger passive house project is an integrated design process. And we didn't start out with passive house as an explicit goal. We talked about it early on. We talked about living building challenge. We talked about a bunch of different things. And one of the interesting things that happened is, we were designing to try to reduce loads as much as possible, which on most projects is where you need to start. And if you do end up with a passive house project, it's nice because it gives you a line in the sand to see if you're actually hitting those reduced loads. But one of the big things here was integrated like passive cooling. So kind of get into that a bit more. But from a target and verification standpoint, you can see this is from our final verification report. So heating demand, cooling demand, load, and cooling load are all there. Next slide. And for energy, because it's net zero, so we have on-site solar and additional solar array down on the lower school, it allowed us to get to net zero, which we'll talk about from ILFI's program. But for air tightness, we were able to hit slightly lower than 0.06, 0.05 CFM per square foot. Next slide. So from a site advantage standpoint, it's kind of like an advantage and challenge. So as Brendan mentioned, there's a lot of trees, and we had to do a lot of analysis on shading. And on-site solar potentials were pretty limited because of that. Between the need for mechanical equipment on the roof, which you can see there's quite a bit up there, and solar, and try not to disrupt having equipment around the periphery for noise and other kind of tree protection purposes. We had a bit of a complex roof coordination. So Dan and our team worked really closely on that. So definitely back to the integrated design process, making sure you're thinking about that early on and have a plan for it. When you've got larger air source heat pumps, which you can see up on the roof, and the more efficient air handling units, they do take up more space often. So that's just something to be aware of for coordination. So other lessons learned. So we worked on RMI, the RMA's passive house project, which many of you have probably seen. This also didn't really start with passive house as a goal. We started with just like reducing loads first. And on any project, whether you go with FIAS or PHI or not, like trying to get those loads down for that climate is the first step. And on Bush School, to mention there was a lot of focus on that. Go to the next slide. We have a high rise in Oregon now, which will be one of the larger FIAS projects on the West Coast. It's a similar issue, but when you get to scale, one thing that we found is with FIAS projects in particular, it can make the actual FIAS review process pretty painful because they're used to smaller scale buildings. So if you do have a bigger building and you want to go through this process with FIAS, just plan for more time than you would expect, because they want to look at every tiny detail, even though like on larger scale buildings, often from an energy standpoint, you start getting into the minutia for returns on savings, but it's just something to be aware of at scale. It changes it a bit. For code installation, the city of Seattle's becoming quite stringent, so it's getting closer to Passive House. The Bush School you can see is not like that much different than code. It's definitely better, but still pretty close. So it's kind of a improvement in the code, which is great. So most buildings are doing much better for new construction. The big difference is the glass, really, versus the opaque walls. Next slide. So yeah, a lot of iterative detailing with Mithun, trying to figure out, especially where you've got different assemblies coming together, is often where you've got the challenges. So we had a number of those details that took quite a bit of coordination, but we're able to work it out with Therm and additional coordination between the team. From a mechanical standpoint, we were being pushed to use VRF early on. We have been sharing concerns about refrigerant impacts for years, and the school project drawdown came out, if you're familiar with that book, while we're in the design process. And I think that and a number of other things, there were some people who became really passionate about refrigerants as a topic, and there's agreement to try to use no high global warming potential refrigerants on this project. So that informed the design quite a bit. So we pulled away from your refrigerant-based distribution systems and try to get a hydronic solution with a packaged heat pump instead of refrigerant lines throughout. So we ended up with a DOAS with energy recovery and air source heat pumps on the roof, which have a 2-pipe changeover system. If there's any mechanical engineers on the project, often, and some architects, you may have had a 2-pipe changeover project go sideways. This comes back to, you have to really have integrated design to do that properly and be able to avoid simultaneous loads and conditions in a building which are going to require both conditions at the same time. So you have to think about design more than a normal 4-pipe system. We did go after ILFI 0 certification, as I mentioned. So it's a 23 kW solar array up on the upper roof and a 142 kW array on the lower school, which you can see on the site plan. And we're officially zero energy ready. So we made it through that review process. I think we would have been certified by now. We just had some data issues post-occupancy where the data trackers from the solar went down. They went offline for a while, so we don't have the actual details. So if you're ever tracking energy post-occupancy, keep an eye on it. It's very common that that stuff goes down and then you have gaps in your data. And just to end with, this project's a real uplifting one for me, because we were in this tight budget situation. The project was going to essentially a code minimum almost. And Mithun, our company, we've been promoting all kinds of sustainability options early on, and we're almost like coaches, right? Like you're trying to coach a client, like, hey, you can get there, here's the things, but like costs came in, it's just like, we're not going to get there, strip everything back. And some of the students' parents came in and said, why aren't you doing more? And we had this really powerful meeting with a student's parent, and just challenged the school to come up with meaningful goals, because he said, it's our responsibility to show these kids that we're actually going to make a difference towards the climate change crisis. And then they pulled together this group of donors for that bucket of funds that Dan was talking about, that was then used to help make this a reality. And way too often I see sustainability funds kind of robbed for program area, even for really well-intentioned clients. So having some discipline and a way to really get serious about this, we need to do this across the board to hit these goals, because it's far too common for projects to fall short of making it all the way. So this one I use all the time as a great example for what clients can do.
No, that's a great mention, dude. I actually bumped into that one of the kind of key champions who was a parent at the school this Saturday night at a solely separate event. Just didn't expect to see her, and she came up and gave me a big hug, and she was like, I'm so proud of what we did. And it was just like this heartwarming like a happy place, kind of conversation. But leveraging the communities, like student voices, these are kind of really key tools in like affecting leadership change on the client side, and also just sharing the kind of stories. There have been 30 tours to this building, and Mithun's probably led about 10 or 12 of those by now, and it's so great to tell the story and have this extend beyond kind of this site and this campus. So anyway, I think we're over time here, Zach and team. So we'll pass it back to you, Sean.
No, I'm glad you guys finished that story. I think David, like that really landed with me. I mean, we know what's happening in New York with the UN and all those kind of discussions this week. And so to hear a touching comment about that the project didn't have passive house fatigue, which we do hear about, and the fact that you guys got a boost from the leadership community to embrace what you guys are doing and to make sure that your work and your mission to deliver a passive house school carried through, and the fact that you had some parents really support you guys. It's great. And I'm giving you a virtual hug as well, because I appreciate that you guys complete this and work through it all, because it's quite meaningful work. My few takeaways: again, love the combination of passive house with your other design goals. Mass timber and net zero energy is great. Again, I've seen those big, massive pieces of plywood come in, and I love going to the mass timber conference just to see the different technology that we've done, where we've we've tweaked Mother Nature with a little bit of glue, but we're able to get some carbon storing in different materials. And so seeing another mass timber product be put into to the process. I love the board form concrete, where where you need to put concrete, at least it does look like wood and has a bit of a texture of some nature. So I appreciate that design. Again, appreciate the training involved and having to probably multiple training of construction teams. And again, love seeing the involvement of a mock-up. Can never have enough mock-ups in our projects. And so I'm glad you guys incorporated that, and that construction decisions are based on modeling, not just these thumbs up being like, hey, let's do this because it's the way to do it. But the fact that you have the model that says, hey, we can tweak things based on performance. And so really appreciate that analysis and the details you guys provided today. So that being said, we'll give you guys a moment to catch your breath, and we're going to head over to sponsors.
Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you, too, to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Bewiso, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And thank you to our patron sponsors, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
Yes, absolutely. Thank you, sponsors. Okay, we've got a long list of questions, some good ones here. There's always going to be the we call it the Harvey question about costs. And again, I think we all need to recognize that that ideally removing budget line items, removing the higher cost of a mechanical system, and removing that budget line items into our windows and to our levels of insulation. So we can definitely get to passive house levels. We're just moving some budget line items. So we'll get into that lovely question about how much does it cost and all that fun stuff. But first, we have Mackenzie, and Mackenzie, you if you want to unmute yourself and ask your question, go ahead.
Yeah, hi. I also work out of Seattle, and I'm curious if your firm does the WUFI modeling and carbon reduction studies in-house, or if you guys have an outside consultant doing that.
Sorry, on mute. Yeah, we do it in-house.
and maybe just to quickly expand on that is, how do you find that part of like that integrated design planning of having it in-house instead of having, you know, a consultant? Because I'm sure when you started, you guys probably used outside consultation and now it's in-house. And how has that improved the speed or even just the information flow as you're trying to ramp up and incorporate Passive House into your projects?
We've always had it. We've always done it in-house. We've never had any external consultants at PAE for it. We tend to have bigger projects, so we don't work on like the smaller homes as much. We did work on one in Oregon years ago, but it's yeah. So we'll often start in IES. So, you know, the heavy lifting is in IES early on, and then we'll use WUFI later just for compliance.
Awesome. Great stuff. Hopefully that answered your question, Mackenzie. Appreciate the added answer there. Ben Station, heading up to Kelowna in BC. We're again ravaged by forest fires, so high performance building definitely matters in all locations, but seeing it firsthand in resiliencies is what you saw this summer. Go ahead, Ben.
Yeah, absolutely. So I'm just wondering, because in the beginning slides, there was in the illustrations you were showing, you know, the effects in utilizing nighttime cooling, and I'm wondering how you guys address the behavior, like the occupant behavior side of things, and just availability of people to operate the windows. Also, security concerns of being unoccupied overnight, where you might have windows operational. Were there security problems with that, or are they? How did you guys address that?
Not really aware of any security issues. Maybe Dan can weigh in on that, but I will say, like, this team, not just the client side, but the operations team was all in on every meeting, and so they weren't sort of like handed a building. It was sort of there was a lot of sort of participation and enthusiasm with the educators and the kind of maintenance personnel, I think, in kind of supporting these strategies. But I don't know, Dan, is there any more specifics you wanted to add to that?
Yeah, I'll just say that I don't know that we ended up with nighttime, flushing. That was an idea. We had motorized operated windows proposed, but the facilities group at the school kind of put the kibosh on that. They thought it was going to be a maintenance issue that they didn't want to have to deal with. I think they had some experience on some other project where the operators failed. So we do have a couple motor operated windows at our stairwell that's being used as sort of a vent stack for the lower kitchen to allow warm air to escape out passively. But we did have to get rid of those motor operators, and there are security or maintenance people that go around the project at the end of every day to make sure windows are closed, but it's all manual operation at this point.
When they have limiters, so we did look at having it fully operable, but because of those concerns, you know, as Dan mentioned, there's only a couple of them, but those do have potential for night flush. The main thing, there is partial cooling on the project, so the air handling unit has cooling on the ventilation air. So this is something that we've been doing more in schools where, you know, because the summer months aren't occupied, you're able to, you know, keep the building comfortable in the kind of swing season, and then summer people are in there, the occupancy density is lower, and with ceiling fans, it tends to take care of it still.
Great.
Great question, Ben. Awesome. George had a couple of questions. Just because the queue, George, maybe you want to just pick your favorite one, and we'll add you to the end if we've got time.
Yeah, it's fine. Well, actually, my question was about the summer vacancy. That schools are kind of unique in that, you know, 3 months of the year, no one's in them. I assume that doesn't change the pH targets, but how does it change, you know, the MEP design? How does it change, you know, how hard it is to get onto that limbo stick in each case? You know, how to talk about that, if you would.
Yeah, we model it based on the occupancy. So like all the energy modeling and load analysis has that baked into it. There are some schools where people want full cooling still, but we'll try to get passive cooling in for the most part, and that Bush School is on board with it. But you have to have a lot of conversations around expectations on comfort and looking at comfort holistically, not just the dry bulb air temperature. Because if you're just focus on the drivable air temperature, you might struggle with some facilities people.
I also want to make a broader comment, George, is just especially with our independent school projects, but also public K-12, there's more of an intertwining of like external users that makes these projects actually work with community interface. And so there are many summer programs that are starting to creep into all the curriculum planning that we're doing. So whether that's conferences or events or education programs and camps, like these buildings are kind of 24/7, like, you know, around the year, with maybe a little bit lighter touch in the summer, but still used.
And just changing expectations, the idea that you can have a comfortable space that's in the 80s with ceiling fans is really important. So like in the Bullitt Center where I'm at now, you know, we get in the 80s regularly here. These school projects can be similar, and it's traditional mechanical design, you know, that's like a big no-no, but you can actually pull it off if you've got the right system approach.
But would FIAS allow you to say, you know, this building is off all summer, you know, there's no lights, there's no pumps, there's all that kind of stuff, or is it, they don't buy it?
Yeah, I think that'd be a stretch.
Yeah, George, unfortunately, principals and vice principals have to come back in August to start planning the schools.
Hey, my brother's a professor, I know.
Going on, and you know, I'm sure there's some summer programs that happen in July, so there's minimal loads, but there's still some loads. And I appreciate David, how there's a ceiling fan in your background, because yeah, again, that ceiling fans can help out those 2 or 3 degrees when we're just starting to get that threshold of comfort. So appreciate that insight. All right, sorry, George, thanks for those questions, good ones. And over to Jane Sanders. Jane.
Gotta get off mute here. I was just curious, there was a foundation detail you showed on early in the presentation and said you made some changes to improve constructability. I'd just like to hear a little more about that, and also to know what the layers of your wall assembly, both on the brick side and on the, it looked like metal cladding on the back.
Okay, I can address that. So let me share my screen again, and I'll just kind of show you this slide again. We went through it a little quickly, but
we were in our happy place trying to avoid any and all thermal bridges, Jane. And then there was a "what kind of crack are you smoking" conversation with our GC that led to some revisions.
Sounds familiar.
So this was the slide we were showing. So this, for example, was the detail where we had the insulation coming up and wrapping up behind these concrete stem walls that were supporting the brick, and sort of sequence of construction and worry that there might be crushing of this insulation as it gets loaded with the brick was the contractor's concern. So what they proposed, and this is their sort of drawing, this gray box, was just extend this stem wall down and sit it on the concrete. You know, we can still tie it in with rebar and have the waterproofing sort of going up and maybe some weeps through here or weep it out up here. But so that's what we ended up doing. We revised this detail to bring the stem wall down. There were some things, so we went through sort of a red circle, green circle analysis of the contractor's comments. So you know, going back a page, they made a lot of comments, and me and team went around and sort of green circle, red circle, yellow circle. Green was, yeah, that's a good idea, we'll do that. Red was, no, we're not going to do that for whatever reason it was. And yellow was, we just needed to do a little bit more research to figure out either what it is they're saying or whether it could be accomplished. So, you know, again, these red marks, these are where they wanted to just kind of make things more monolithic. And so we had to push back on some of these things that we said, no, that's just not going to work from a passive house standpoint. And the thermal bridge there is too systemic and we can't handle it. If it was kind of a one-off thing or, you know, something like that, we were able to push back. As far as the brick detailing and versus the metal detailing, I guess we can kind of see here, but I have our drawing set here. I was just going to show you. I mean, the metal, this is the brick detailing, for example, typical just brick, airspace. We have 2 inches of mineral fiber insulation, plywood, because most of our exterior walls are shear walls, and then R19 bat insulation in the cavities. So that's a typical brick side, and on the metal side we have AEP span, standing seam, vertical siding, again 2 inches of mineral fiber insulation, maybe more. It looks like a little bit more than that, but and then this is just different scales. That's why. So 2 inches of mineral fiber, and then again bad insulation in there. And here's our Cascadia windows detailed in there.
Just a quick comment that this is where like those trees and all the kind of zoning constraints, there's a tight lot coverage piece that we don't need to get into the detail of, but we had to work from that outside face in. And so double studs or other kind of strategies started to really impinge on like minimum classroom sizes and made the product not work. So there was that a sweet spot of kind of that 2x6 assembly that Dan just mentioned that seemed to be hitting the performance goals, but also preserving our GSF and ASF.
Yeah, love those details. Again, beautiful jewelry, rain screen detail, outsolation, and then the structure. So beautiful stuff. We're gonna hold off, or sorry, Danny, do you want to go through another detail?
Yeah, I was just gonna say this was, I was kind of highlighting this in preparation of this meeting. Like, the yellow is our insulation line. So we weren't, there were some pushbacks by the contractor where again we have some thermal bridging, but again just trying to trace that line up around the project and how it comes down the other side. We have a patio here, insulation on both sides. So we did try to maintain those lines of insulation around the project, and
maybe
bridging.
George had a note about brick and just the embodied carbon. We did actually sort of think about that and the idea that the building massing is actually broken into 2 parts, and the majority of the project actually is metal. It just presents a minor amount of brick to kind of be part of the campus fabric. So there's a little bit of a scale break, but also kind of a carbon mitigation strategy with the overall kind of stepped massing piece. But we're probably taking up too much oxygen here. So pass it back to you, Sean. But appreciate all the great questions.
So we're at the top of the hour. So if you do need to depart to head back to work or get your day started, or if you're overseas and the time frame is getting to your bedtime, we do thank you very much for joining us today on amazing Passive House Accelerator Live, where we got to showcase the amazing Bush School. I think a couple of our presenters have to hop off, so we will stick around for kind of our final 15 for as long as we can keep everybody. Again, thank you very much. And I just have to say, a call to action. I hope that you will take this presentation when it becomes live in a few days and email it to your school trustees, your principals, city officials, so that they are aware of this amazing school and how they can be looking at adopting a Passive House school in their school area. So I've got to give you some homework, and share the presentation to your local officials so that we can build more Passive House schools, because as you saw today, it's beautiful, and the level of details and the collaboration they did with all their design goals created an amazing school, and I can't wait to see it in person one day, because luckily it's just down the I-5 for me. So great presentation by David, Dan, and Brendan, and I know you guys have to jump off, so whoever is going to stay will continue asking questions. And it's actually my turn. So when does the original school get the retrofit?
Sean, that's happening actually right now. There's a major boost of that existing historic building. That's I think it's getting close to completion. Dan, I'm not sure
Yeah, I don't know the timing, but I think they're just a few months away now.
Awesome. Great stuff. Again, love how we start with the new and then work on the old, because the retrofits are coming, folks. Fast and furious. I know we have Retrofit Canada here, and lots more conversations of how we're going to be fixing all of our old leaky buildings that are not comfortable. We are back to William. William's met William today. He's looking at building a passive house and living building challenge in Pennsylvania. So William, go ahead and ask your question.
Yeah, hi, that's right. And one of my questions is how you balanced solar generation with maintaining trees. I have a design near the forest, and I'm trying to figure out that balance myself as well right now, especially with low winter sun. Manage that.
I don't know if David Mead, are you still on, or did you have to drop off? I think he dropped off. Well, I know PAE did some solar studies. Can't remember what program they used. They modeled tried to simulate modeling of the trees and to figure out which areas. I mean, the building is not all that big, as you saw. There's a lot of mechanical equipment on there, so we don't have a lot of areas on our project proper that could even have the solar panels. I think we have I think it's a 14 or 18 kilowatt array on the building itself. But the lower campus had much better solar access. So we have about 160 kilowatts down on the lower campus dedicated for this project. We also engaged a design builder at some point who's A&R Solar, for those folks around here who know that company, a really good solar company. They did their own modeling and had their own suggestions of where panels would be successful, and we had to modify the design a little bit and move panels around, and they became a little bit more realistic with how much we could get on the building and have it be functional. We didn't want to waste the school's money by putting panels just for the sake of putting panels if they weren't going to be functional. There was a threshold. I don't remember what that threshold of like performance of the panel that made it worth doing.
Makes a lot of sense. Yeah, having somebody on that installs solar, being able to answer those questions and model it. Yeah, it sounds like a good approach.
Yeah, well, and just remember though, is your trees are great because they give great shade in the summer, and then those leaves disappear in the winter, and you kind of get those low. It doesn't quite happen here in the Pacific Northwest, so it's a bit more challenging for
Yeah.
course. But again, and also solar panels look great on the ground. And as I indicated, the Passive House project and Living Building Challenge project in Cowichan Bay called Green Point, they put their solar panels on the ground close to the shore, so they didn't have it on the roof. So look at different options.
Brilliant. Yeah.
Easier to clean the solar panels are on the ground. When they're on the roof, it becomes challenging to get snow off them too. So look at those considerations. Okay, we got Dan for a few more minutes. Jane Sanders, we're back to you. And as Kim said, thank you for being a sponsor this week, and thanks for joining us. And I always love your questions and your project. So thank you so much.
Sorry, I didn't mean to take up all the questions. I was also curious about the glass in sort of porch room. Was it difficult to have so much glass in the model? And is that, I assume, is that the south side and the overhang helps with that?
Yeah, that is actually the west.
Oh, okay.
The site's a little funky north, but it's kind of mostly northwest actually facing. David's not on anymore, and as far as the energy modeling of the building, there was a lot of scrutiny over that space and how successful it would be. We were really trying to create a bank of glass that we could create this, front porch kind of space that really is somewhat atypical, I think, of a passive house, traditional passive house project. So, the main envelope of the building you'll see has not small windows, but smaller windows, a healthy, robust envelope. A lot of the project is below grade, and so we were able to kind of bank up some of that glass and use it there. We have 6 ceiling fans in that space, operable windows, shading from the trees that are around there because it is nestled right behind a whole bunch of trees. I think all those things, there was a comfort analysis done because at one point we had full cooling to the building, and we ended up having to value engineer down to kind of a partial cooling approach. Yeah, all those things enabled us to be able to have that space, have it be successful. Getting it airtight, if that's part of the question, from an envelope standpoint, the Cascadia windows are very good, and a lot of scrutiny over, sealing up all the joints where beams were penetrating and going back into the brick facade. That was one of our more challenging areas to get airtight, I will say, but they did a great job.
Great,
Yeah.
thanks.
I can just say those details result in a lot of taping. So tweaking and so gift wrapping was on par for those details. So great stuff. We got a couple more. So James, if you're still with us. Go ahead and ask your question, James.
Hey, Daniel. Great project. I had a couple questions related to the storefront doors. Was that also Cascadia? I know those can be kind of tricky when it comes to passive house buildings. And then as well as what's been your biggest success with kind of coaching clients at the beginning of a project, kind of through this process?
Well, the storefront doors are not Cascadia. We have some back doors onto that back patio that are Cascadia doors. But the front doors, which have a little bit more hardware components to them, were not really going to be successful as Cascadia doors. So they are Conair, aluminum frame storefront doors, so that we can get all the hardware components in them and a little more durable. The success of air tightness of those things is a good question. I can't speak to that at the moment. I wasn't doing the day-to-day CA on the project, and so I don't know if they had to do particular measures of added seals and gaskets to get those doors to be successful. So apologies there. As far as successes in coaching the client, I think our menu of ideas really helped them hone in on we did a lot of sustainability charrettes with them. Tried to suss out of them what was really important from a concept and mission for them, and it the stories we were hearing from them kind of led us to Passive House. They were interested in energy, they were interested in carbon, they were interested in healthy environments for their students, and all those things are nicely packaged in Passive House. And so it was great for us to be able to pick a system that really aligned with their mission. But breaking it down into bite-sized pieces on this menu that always tracked code versus the upgrade, and they could make choices and they could see what they could afford, and we were always testing around the Woofy model, really helped our team get over that hump with them and keep it in the project.
Great, thanks.
James, that second question is great. And Dan, great answer. I know that literally could be a whole nother presentation. And you know what I just thought of, Kim and Zach, is maybe that's a great Passive House Accelerator Summit called Kicking Off a Passive House Project. And if you know me well, you know how you'd spell the word off in that context. So great question, James. Michael? Michael's still with us. If not, I'll pull up the question real quick. Did you compare the embodied carbon benefits of mass timber and the operational emissions of doing Passive House? And I think the answer is yes, but I'm just I know we got about 4 minutes left. So Dan, maybe you want to dive into that quickly.
It's a good question. I'm not quite sure how to answer that one. We certainly looked at the carbon story of wood versus steel, as we showed in some of those slides. EUI target goal of reducing carbon and energy use was definitely analyzed. We're at an EUI. Our target was 21.7, and I think we're tracking below that, 20 point something at the moment as we analyze the data from the past year. So the answer is yes, but I'm not sure I have a more technical answer to it than that.
That's a great answer. We'll stick with it. Mackenzie just stepped away from her desk. And do you want to go ahead and ask your question, Mackenzie?
Hi, kind of a nitty-gritty question, but I just noticed that the rain screen on the storefront detail was running horizontal, and we had I think it might have even been PAE, but another consultant do that on a project. And I haven't seen that before, so I was curious if what the intention was there. Normally we see those running vertical.
You're talking the detail that I showed earlier with the kind of hat channel.
Oh, hat channel? Yeah.
Yeah. Well, we have Cascadia clips as our cladding support system for the metal, and those run vertical. And then I think the channels are running horizontal. I'd have to look back at construction photos to make sure that's actually how they installed them. Could be that we drew them backwards, but I don't believe so. I think for the Cascadia clip, that is a typical installation where those hat channels will run horizontally, and then you can attach the vertical metal side. I guess it depends on which way you're running your metal siding as well. Ours was running vertical, so we needed the channels to run horizontally.
Okay.
Yeah, McKenzie, if I get with that too, I mean, you're cross strapping your rain screen to make sure that water flows down and out. And depending on you might be either leaving an air gap of something or putting a kind of a piece in there to make sure that water can get past it so that it doesn't get caught up by your horizontal strapping. So water will definitely get down and out. And because it's Pacific Northwest, there's lots of water. So we got to make sure we take care of it if it gets behind our water shedding surface. So, and okay, the last question, I think Jose, you got yours questioned. Sorry, just checking. I think we're there. Kim, I think we're there.
That's it. Yep.
Hey. Well, Dan, appreciate you sticking around for the final 15. Amazing presentation, an extraordinary project, and maybe we have to bring you back for when the retrofit is concluded. And as James kind of asked too, maybe we need to bring you back for a Passive House Accelerator Summit about how to kick off a Passive House project. So a few things. Hope everyone takes away their homework to make sure that they forward this presentation to your local officials and say, hey, look, there's a Passive House school. Our students should have Passive House schools in our local area. So please do that. And again, a big thank you to Henderson Architects for being the sponsor for the Accelerator this week. Jane, appreciate again all the work that you and your firm do. And again, really appreciate the support. And next week on Passive House Accelerator Live Construction Tech Edition, I will be back with our amazing other co-hosts, Kevin, Shannon, and Mark. And we get Maureen Sanchez from RDH, who I have to check the score and tally, but I definitely know this is her third presentation, but might be her fourth when we include that she was really the first presenter of the predecessor to the Accelerator Live, which was the Happy Hour, where Maureen talked about some of the amazing work that was going on in the early years of her time at RDH. And crazy to think of where everything's become and how great the Accelerator has been. So appreciate you joining Zach, Kim, and myself and the rest of the Accelerator team. I got to step in for Bev. She'll be back next month. And so hopefully we wish her a quick rest up and getting over the fun sicknesses of September and all the fun stuff that happens with kids going back to school, and a great project showcase featuring the Bush School. So Zach, Kim, I'll let you hit the ejection button, but always great to see everyone.